Hello everyone, Xiaogang. This part wasn't wrong, sorry. I misread it. Anyway, remember that if it is less than 0, then obviously 1 and 2 are out of bounds. If it equals the element number, it will definitely be out of bounds. And if it is greater than the element number, it will also inevitably be out of bounds. So the reasonable range is from 0 to this number minus 1. This is for double arms. Both ends must have the correct index range. It should be this. Let me correct this part. Let me correct it. Next, let's talk about whether it includes a specific element. The use cases for this are quite numerous. Sometimes you apply a buff to a player. You check whether or not it currently has this. For example, taking burn damage, or when taking frost attribute damage, then we generally give it a structure. Inside this struct, you will record the type of damage, whether it has a cooldown or if this time has taken effect. And if an element of this type is detected, the element exists, then we let the damage calculate multipliers. So this content is quite important, and it is relatively complex. Then it can also pass the position in this way. To perform a very simple check, we first write the simplest contain. Okay, we put this here. We also start another one. We call it the continent array. We create its instance. Then we will still use it here. Hello world from tomorrow. Hello tomorrow, and then just stick it on like that. Okay, let's check this area. Be hello is a be word. Be goodbye. Let's see if there is this goodbye. Obviously, one has it. And one does not have it. Then let's take a look at inside this container. This annotation just says check. Is this element? It contains this element. Return it if available. Otherwise, it doesn't exist. Okay. And then, for this f distance, we generally have to overload it with symbols like this, and so on. This way, we can verify if it is a state of equality. Then, we will still run through it for everyone following the standard procedure. When you execute it, don't write the code here, because if you write the code now, there will be an issue. If you run into a breakpoint, it will prompt you to modify it, and a window will pop up. You must either accept or discard the changes, or just abandon this breakpoint hit. So the situation is like this. What we wrote here should be called. Looks good. Okay, let's execute it. Okay. If it's true, there are absolutely no problems. Let's continue moving down. We attach it, and then the following. It can also pass a lambda. Passing a lambda. The function signature of this lambda, it looks like this. It will determine, then it will initiate this cycle. So what is this mechanism? This mechanism simply means that when it interacts with the host and passes in this element, and if it finds something, if this location returns true, it proves that it includes. Then it means the current search ends once this result is found. If forced, it will continue to execute. Then let's simply continue implementing it. Okay, we can actually see that this searches for 5 characters. We have 1, 2, 2, 3, 4, 5, 1, 2, 2, 3, 3, 4, 5, 2, 1, 2, 2, 2, 2, 4, 2, 5, 4, 2, 1. Similarly, this also searches for 6. We have 1,203, 4,506. We shouldn't count 6 characters. Then we can take a look at its circular code comment. Then check if this element contains, say whether its array contains an element, and this particle judgment, when it is true, then actually we want to see how many times it executed. We can write a log here. For this place, we just write log time. Let me elaborate a bit for everyone. And regarding this part, we will give it a And here we need to give a positional placeholder and give it a rectangular positional placeholder. And then we might need a static one, or let's do it this way. We don't need static. Here we will give an interchance out be free 5i charge. Excuse me, please point to the left. You don't need to worry about getting it. Let's come back here. We'll give it a 0. And then every time we enter, we need to capture the address here, because we need to continuously modify the same variable. So what we are intercepting here is the address. So we can do it like this. What we capture is the address of this variable. We make it increment here. So we use pre-increment, because when you put it on a separate line, using pre-increment and post-increment is actually the same. So similarly, in this place, we do it this way as well. Then here we do this. We reacquire it. Note that we captured 6. This place is 6. Don't pick the wrong one. It's not 16. Okay, so this place is also 6. Look, if you didn't capture it, it will tell you that this variable cannot be used, because he doesn't know what it is. You can just display and capture it, but you can capture it privately. You can directly have him capture this variable from everyone. So we've completed such a simple test. In order to ensure that we can test this effectively, let's have him add some weird variables. We'll add some weird sudden death parameters. Don't want pixel 6. Okay, give one more. We won't give 6. Cannot give 6. Okay, let's take a look. There seems to be something extra in this area. Nothing at all. Let's take a look. Can it execute stably? We can check this out. Okay, there's an error here. Let's check the error. Don't look at this error list. We can turn off this error list. Let's see how to turn it off. You can just disconnect it here. We don't need it. Let's just check Outlook. It shows up in this spot. We made a mistake writing this part. There's a grammatical error. So clearly, we wrote this part wrong. So we need to put this here. Don't include B here. This is incorrect. We can't use B, because only Boolean types start with B. That's an error. Okay, that should be fine. Okay, you still missed the semicolon. Okay, no problem at all. Let's start. After restart, we execute it now. Okay, then we come in and look at this DAX array. The reason it didn't enter was probably because we didn't modify the blueprint or clear the breakpoints. Maybe it's because of this. We forcefully closed the editor earlier, which resulted in the modifications to the editor not being successfully saved. That's the reason. Actually, there's another tip. Let me explain this to you all for a moment. Here, this part shouldn't have any problems, right? Because this element is here. Then when it goes by, it doesn't go by. Then we can set a breakpoint. Let's see if it can execute up to here. Come on. This place is currently the 0th time. We can see that the past element is 126. 5677, but it might be wrong. Let's continue going down. It's the 2nd time, right? After the 2nd execution. So the principal passed in 33, proving that he might be looking for it sequentially. Then we cancel it out. We go directly to this place. Obviously, this can be found, right? And you can see it executed if it should be 0. I see how many times it executes for 0, 1, 2, 3. It must execute many times. It continues executing up to this point. So 1, 2, 3, 4. So it executes 4 times. So there's this technique with the number 4. After it finds the first element, he won't search anymore, because going there already includes it. Then we continue going down. We will simply make him walk to here. So it's obvious that altogether we have 1, 2, 3, 4, 5, 6, 7. Alimo, he should win 8 times here, execute 8 times, and give a force. We tried moving like this. Okay, look, this is pulse, 8 times, proving that it covered all elements. Okay, so we'll just let it here. We won't let it shut down like this. Then we'll teach you a small trick. Actually, in this area, this should be a blueprint tip, which means if you successfully compile it, let it autosave, or always make sure it saves. Right? And then I usually enable this. It saves if the compilation is successful, but if you don't enable save on compile success, you call it compile save. Compile save. This is a very simple blueprint habit. Okay, then we continue looking down here. We can use the number of rooms in this pattern to find elements. Then it will return this index. So it returns an index like this. It passes two variables. The first is the type of this element. The second is this, the index it fills. Then these searches starting from this search is starting from the end. Then they all return a boolean, indicating whether an element has been found. Then if an element is found, it will write to this index. Then you can also not pass it. If you don't want to do it that way, you can treat everything as a display standard. You can use this way. That is, you want to directly skip this one. Use index. Actually, it should be -1 so if it doesn't find it this way, it will give 1. If it finds it, it will give this element. And this file, last means searching backward, and find means searching forward. Okay, let's do a simple demonstration. Because this is relatively simple, we still have to write it. We just write them all together, okay? Like that. Because after we gradually get proficient, we can speed up our efficiency. Let's write it in CanCan instead. We call it findElement. Then we go to this place and create its implementation. First, let's give it an element. This time, we will write the element more simply. We delete these from before. We call it Hello World of Tomorrow. Give an exclamation mark. And finally, we add one more. We are in the Hello World of Tomorrow. Let's give another hello here. Okay, so obviously we can use if we look for the simplest way, it should be this. We can find it like this. That is through this method. So put this place to hello. This index should be equal to 0. No problem. And actually, personally, I prefer you need to put this side into a simple discretization. Then we can click on this place. See, this location is a reference. This location is also a reference. This looks for an element inside this host. If it finds it, it will do this, and then a boolean, and then perform a simple write to this element. We can also go and start looking from the back end. We give a last index. Then the indices it provides should be 1, 2, 0, 1, 2, 3, 4. So that should be correct. We can now execute these two. Okay, let's execute now. We can use this boolean as a receiver. Then our method won't need an if statement. We can do it like this. Actually, this kind of if false writing is very common, especially when returning pointers. We can do bIndex. bFindB last index. There might be a misunderstanding here. Let's stick with indexing from the last one. So it comes from the back. Here we should use FindLast, and then we pass it into this spot. For example, there's an extra parenthesis because we don't have the if statement anymore. Okay, so let's run it now. Wait, we can still do this? Let's find another one that doesn't work. We'll put one here. When writing, make sure you write correctly in the spot. it needs to correspond, which makes it very clear. Let's pause for a moment and start it up again to check. Okay, then if we stop checking, it should be here. Let's find it. Find. Allez. Then we proceed into it, and after finding this index, it should be 0, because it's the first one. Then we look back and search from the end. It should be equal to found, the last one that equals 4, right? Then we use this to search. This spot is still -1, because it can't be a negative value. This place just waits for false. Basically, this is demonstrated. Okay, if you say I also have a hello world in the middle, how should I do it? You might need to use this byPredicate yourself for this, using this kind of byPredicate, or you can manually cycle through it yourself. So I kapta it, because these are essentially, it provides you with some ready-made syntax, sugar, and sometimes you might not want to pass the index, because when passing it to this location, I hope to do it directly when declaring it here. We can just use the starting point. So you can do it like this. You can accept it up front. Then it will be flipped at the index long. Actually, let's apply it to this spot. We should write it here instead. We will just remove this index. So this index will not cause a simple conflict with the previous one. Then we can look at this index loss. We can look here. We can search for it. We can perform a full text search on the index. This is quite important. You can see that because we often use this index, you will find that, take a look at this plate. Then this should be correct. It is called call magical diffusion. And this place has an index equals -1, right? Click on this spot. Always index. They should all be this. So it defines this thing as -1. That's what it means. This is often one that we frequently use. Should be it. Right. We can write one like this. Boolean index null. Okay, let's check if the index is null, like this. Whether it equals index null. Okay, let's try implementing it now. Okay, we should be able to start directly here. Okay, let's just skip down here. We don't need to look at the top part. Similarly, looking at this place, it should be given a 0. This place should be given a 4. And this place is given a -1 out. And over here should be given a true. Okay, no problem. Okay, alright, so in our next class, we'll cover up to here in this lesson. We will continue teaching it next time.